array address calculation in 1 and 2 dimensional array. As we all know that array is a container object that holds fixed number of values of a single type. That is of same type of values are stored in contiguous memory location in an array in the computer memory. So to calculate the element of a particular calculate the address of a particular element of an array, there are different formula we use for one dimensional and two dimensional array. To calculate the address of an element in one dimensional array, well, we take care of three elements, that is base address, size of each byte, that is W width, and the lower limit of the indexes. Now here, for example, in this one dimensional array, we have 6 elements and the lower index is 0 as mentioned over here, and the base address is mentioned as 1100, and the width size is or the byte size is 4 byte for each element. Now to calculate the address of a particular element in a single dimensional array, we follow this formula, that is b plus w into I minus lb, and the address of the element that we want to find is ai. So now where b is the base address, w is the byte size or width of each element, I is the subscript of element whose address is to be found, and lb is the lower limit. So if it is not mentioned in the question, the lower limit, then we'll assume it as 0. So now here in this question, the question is given the base address of an array is b 1300 1900, where the 1300 is the lower bound address and the 1900 is the upper bound, as 1020 is the base address, and size of each element is 2 bytes in the memory, and find the address of b is 1700. So 1700 is the subscript of the element whose address is to be found. Now using this formula, we find that b is equal to 1020, lb is 1300 as mentioned here in the question, width is 2 bytes, and I is 1700 as mentioned in the question, and after calculation we get 1820 as the answer of this question. Now to calculate the address in a two-dimensional array, in one dimension it is not that difficult to find to calculate the address, but in case of two-dimensional array it's a bit different. So address calculation in two-dimensional array, while storing the elements in a two-dimensional array in memory, these are allocated in contiguous memory locations. Therefore a two-dimensional array must be linearized so as to enable their storage. There are two alternatives to achieve linearization: row measure and column measure. So normally when we show the elements of a two-dimensional array, we show in a tabular form. Suppose these are the rows and these are the columns. Now to linearize these elements, we can linearize it in two ways, that is row by row or column by column. Row by row system, we take 8654 as the first row elements first, then the second row elements 2197 second, and the third row elements 3642 the third, and this is called row measure. And in column measure, or you can say column by column, if we arrange it, so the first column, then the second column, third column, fourth column. So here you can see 823 is coming first, then second 616, 594 and 472. Like this we can linearize the data. And the formula to calculate the memory address for row measure and column measure is different. So in row measure, we use this formula to calculate the address. Suppose if we want to calculate the aij, where I is the row subscript and j is the column subscript, the formula is to b plus w into n into I minus lr and j minus lc. So I stands for the row subscript, b as well as for the base address, j is for column subscript, w is the storage size or the byte size, lr is the lower limit of row, and lc is the lower limit of column. And here we are using n is the number of column of the given matrix, the total number of column. And in column measure, the address is, suppose if we want to calculate the aij, the address of element aij in column measure wise, then the formula is b plus w into I minus lr plus m into j minus lc, where the b is the base, w is the byte size, I is the row subscript, and lr is the lower bound of row, plus m is the number of row of the given matrix, and j minus lc, j is the column subscript, and lc is the lower bound, lower limit of column. So these normally the lr and lc is mentioned in the question. If it is not mentioned, then we'll assume it as 0. So one very important thing we'll have to take care while calculating this is that usually the number of rows in columns matrix are given like a 20 30 or a 40 60, but if it is given number of rows, m will be calculated as a lr, sorry, but if it is given as lr dot ur and lc dot uc, in this case number of rows and columns are calculated using the following method. Number of rows we can calculate using ur minus lr, and number of columns will be calculated uc minus lc plus 1. So, and rest of the process will remain same as per requirement, row measure wise and column measure wise. Now, for example, in this, an array x minus 15 10, you can see the lr and ur, the lower bound and upper bound of row, and lower bound column and the upper bound column is mentioned here like this. Requires 1 byte of storage. If beginning location is 1500, determine the location of x 1520. So here, if you see, as you see, the number of rows and columns are not given in the question, so they are calculated as number of rows m into ur minus lr plus 1, that is 10 minus 15 plus 1, that is 26, and number of columns is uc minus lc plus 1, that is 40 minus 15 plus 1 is equal to 26. So this you will have to keep in mind before attempting any question related to address calculation. So here two examples we have given. Suppose an array x is equal to 15 10 15 40 requires 1 byte of storage, so the width is given as 1 byte. A beginning location is 1500, that's the base case. Determine the base address, determine the location of x 1520. In column measure, if we go, that is base is 1500, b, w is as mentioned is 1 byte, I is 15, j is 20, that is already mentioned in the question. But in lr is minus 15, lc is 15, m is 26. M is 26. So this we have calculated from here. Suppose the number of rows m ur minus l plus 1, 10 minus 15 plus 1 is 26 is mentioned over here. Now if we go by the formula, aij is equal to b plus w into I minus lr plus m into j minus lc. So if you're 1500 plus 1 into 15 minus 15 plus 26 into 20 minus 15, then 1500 plus 1 into 15 plus 15 is 30 plus 26, and 20 minus 15 is 5. So it's 1500 plus 1 into 160. So 1660 is the answer. And the row measure wise calculation the same. The B is 1500, W is 1 byte, I is 15, J is 20, LR is minus 15, LC is 15, and N is 26 as calculated over here. So, and then if you calculate this way, you'll get the answer as 2285. Thank you. This is all about how to calculate the address of a particular element in two-dimensional array. In the notes itself, I have included many questions related to this. You'll find different types of questions over here. For example, this question: given the base address of an element of an array A 1200 1400 as 1000 and size of each element as 2 bytes, find the address of A 1350. This is a single dimensional array. So B is base address is 1000 as given, lower limit is 1200 as mentioned over here, width is 2 byte, and X is 1350. So here in this we have row subscript of the given element. I'm using X over here, so I'm showing it X as the element index number of the element. So same way, if we calculate, we'll get 1300. And in two-dimensional array, in this another question, you can see that 10 rows and 12 is written in a little different way. A two-dimensional array T is created in row measure format with 10 rows and 12 columns. Its element occupies 4 bytes storage space. The base address of the array is 2000. Find the address of element 56. So here base address is given in 2000, LR is 0, LC is 0 because it is not mentioned in the question. So we have taken as LR is 0 and LC is 0. And width is 4 byte, is already mentioned over here. And column is 12. X is 5 and Y is 6. So row and column respectively. So if you go, if you calculate this, you'll get the address as 2264. Now here I have shown you different types of questions which has been asked in the exam. All types are mentioned over here. I think you can now you can easily find out and easily calculate the number of rows and number of columns as were applicable. For example, in this question, an array X minus 10 10 minus 12 10. So now here is the lower bound and upper bound is mentioned of both row and column. The base address of the array is 1200. Find the location of X64 if the array is arranged in row measure format. So these are the questions which came in different board exams. So basically you'll find the questions in the in board of this type only. The variations are already mentioned over here, and accordingly you can calculate the address. I don't think that you'll find any difficulty now in calculating the address of a particular element in a single dimension and two-dimensional array. Thank you.